The first keynote is by Peter Wang, Python, and data past, present, and future. So, Peter Wang is the CTO and co-founder of Anaconda, previously known as Continuum Analytics. He's had a long experience in scientific computing and data visualization. He's a great evangelist. His talk on Python Evangelism 101 from Sci-Fi 2010 is one of the funniest sci-fi talks ever. His energy, enthusiasm, and how he engages with people is inspiring. So I welcome Peter Wang.
Thank you very much. I'm very excited to be here. Thank you very much to the organizers for inviting me. This is my first time in India. I've been having a great time. It's absolutely amazing. I'm sad I can only stay for a few days. But what I'm going to talk about today is that, I'm going to talk about Python for data analysis and what, how we got here, what brought us here, and then some of the things that I think make it very powerful and things that can take us into the future. So I'll start with just my journey with Anaconda. And just to give you a little bit of background of who I am, I actually have a degree in physics. I'm not actually a formally trained software developer or computer scientist. I actually got my start in the industry doing computer graphics in C and C++. And then I went on to where I really started getting involved with Python was around 2004. I joined Nthought, and I was there for about 6.5 years. I did a lot of consulting work, I did some open source work. That's where I met a lot of really nice people in the Python community. And in 2012, I founded Continuum Analytics, which is now renamed Anaconda. I founded that with my colleague Travis Oliphant, who is the author of NumPy and SciPy and a number of other things since then. So over the last 5 years or so, I personally launched and created the PyData sort of organization and community. Travis really created he was the seeding energy behind NumFocus. And then we built, of course, Anaconda. I really helped get the Bokeh project started, and that was part of my vision, as well as Data Shader. And then Blaze and Numba, all these other things kind of followed from our efforts since then. And so, in addition to actually doing my actual job as CTO, I manage things like product engineering for our enterprise products. I spent a lot of time thinking about the future of Python for data analysis and for machine learning and these kinds of things. And I think about it really from a very critical and somewhat paranoid perspective of, this is all great right now. It can be better, okay, it can be better, but it's great right now. But what could make it all go away? What could, doom us to be forced to program in some other horrible language or something? And so I spent a lot of time thinking about that. So you don't have to. No, actually, all of us have to think about it. But that's one thing that really I fixate on. And so, if you think back to the kind of early 2012 when Travis and I started the conference, or started the company, we had just attended the Strata Big Data conference, and that was 5 years ago. People were talking about big data. I don't know how much people talk about big data over here, but in America, it's really waned. It's not as sexy to talk about big data anymore. Now it's all AI, right? Everyone talks about artificial intelligence and robots. But back then in 2012, people were talking about big data, and that's, we had a small PyData event. That was our first PyData workshop event. Right after that was March, and so these are some of the slides from his talk at that conference, or at that workshop, that first PyData. And so he had this provocative slide where he was saying, at Strata we see all these things about elephants and Hadoop and more elephants and more Hadoop, but where does Python fit in all this, right? Tutorials, the data science stuff people were doing was all in Python or R. He was convinced that he could actually, could we do things to take Python and have it do more in the big data space, maybe even swallowing the elephant? You guys recognize the picture from The Little Prince. And he was also saying sort of these controversial things like, well, we should build compiler infrastructure so that Python and C are equal high-level languages on top of a LLVM-based runtime, and things like that. But nonetheless, the point of all this is that we were not content with the state of things. We saw that Python was popular, but it was definitely challenged, right? People had really lots of Python versus R. Is Hadoop just going to destroy everything and we should all just learn MapReduce and Java? And so we were not content with this state of things, and we saw that Python could play a very significant role, very prominent role in the future of data analysis. Now that PyData workshop is also very interesting. Remember, this is 2012, because we were very fortunate to have Guido show up. And so this was a small 50-person thing in a little classroom at the Google headquarters. Guido was working at Google at the time, and he found out the event, and he came over. And we talked to him about things like a matrix multiplication operator, or having the ability to quote expressions and become more Lispy, like that. But we also tried to talk to him about fixing Python's packaging problem. And so actually you see over here, that's Travis Olive in the middle. To the left is a much younger Wes McKinney, the author of Pandas. And so we're trying to convince him, Guido, please help the core development team, the Python core dev, understand the pain of Python packaging for scientific Python. Can you help them get them to help us with the Python packaging problem? And Guido basically said, feel free to fix it yourself if the core community doesn't really do it for you. So, so we did, and that we felt like that was our permission, because there had been a lot of even when I was at Enthought, many of the developers at Enthought who were working on EPD, the Enthought Python distribution, there was a lot of back and forth between the SciPy and NumPy maintainers and the EPD creators and the core developers around eggs and setup tools and easy install and all this other stuff. And so, we felt like this gave us permission. And so since then, that really was the birth of Conda and Anaconda. And we have now, actually we're much more than 500, we're well over 700 something Python packages inside Anaconda. And it's the Conda package manager that we have has a really unique capability in that it is, I would say, the only cross-platform, cross-architecture, multi-language package manager. And it's really quite something. It's not very popular for R right now, but a few R people that we meet who do use it love it much better than just using default prim. So it's a kind of a neat thing that we built, and we're very proud of what it's done, and it's only set up for more success moving forward. I just want to show you guys a snapshot of what our download graph looks like over just the last few years. At this point, we have over 20 million cumulative downloads of Anaconda. We're something on the order of 2.5 million to 3 million downloads of Anaconda and Miniconda every single month. And we see it spike at the beginning of the college semester in the spring and the fall. So it's very popular right now, and it's growing. The curve is continuing to go to the right. And that's, of course, due to the growing importance of Python in data science and machine learning. And many people are adopting it as the default. I think the latest Stack Overflow blog identified Python, just the language, as the fastest growing language that they see. And then also, I think Katie Nuggets just recently did a data science poll of 16,000 data scientists, and they showed that Python basically is the de facto language for machine learning at this point. Not that R doesn't do things, but Python is something like growing, it's growing massively faster than R for this stuff. And that's, of course, greatly fueled by the popularity of TensorFlow, the availability of things like PySpark. So anyway, it's really nice to see now that we're on this trajectory, because in 2012 it was not certain that this was going to be the case. Many people were convinced it was going to be all Hadoop, and there was this weird Spark thing that was starting, so maybe it was going to be Scala, but Python's this weird scripting language with a bunch of scientific folks talking about matrix multiplication. Turns out matrix multiplication is actually pretty important. So other problems that we set to solve in 2012, these are things that people were saying. Those of you who are more than 5 years old will probably remember this. Number one, performance, right? You had to choose between a vectorized system like NumPy or going to Cython or even down to C. And there wasn't a nice JIT like Julia. So a lot of people were very excited about Julia. In fact, Fernando Perez, the creator of IPython, he was such a big fan of Julia that he took those two letters, JU, and put them in the front of the renaming of IPython. So the JU in Jupyter stands for Julia. And so a lot of people were very enamored with Julia. I think that if we hadn't made progress on getting more tools into people's hands and building things like Numba, that we would right now be having a lot more Python-Julia kind of like language wars. There's also this problem where web visualization was, first of all, web visualization at V3, and then interactive data applications, lightweight data applications like what Shiny provided for R, there was nothing like it available for Python. You had HTML5 widget, HTML MPL, HTML5 for MPL. There's a weird long name. It was matplotlib HTML5 backend thing. But that was pretty much it. So we created Bouquet, a ground-up library that's a JavaScript and Python library for doing interactive web applications and sophisticated kinds of graphics. And then there's problems like there was not good parallelism for Python, not a good parallelism story. You could do multiprocessing, you could do like MPI things, or you have to go and start learning this like Spark stuff. And so in the creation of Dask, and then creating higher level data structures that were parallel by default in Dask, I think that we've really helped plug that hole, or starting to plug that hole in the Python ecosystem. So these are all problems that we saw. And I think it's really important to just, the reason I bring this up is because some people, I mean, Anaconda now is actually more well known than Continuum. That's one of the reasons we named the company. But many people, I think, have the impression, the wrong impression, that we set out to create Anaconda and to create a package manager. And somehow like that was all part of the grand plan. But it's really important, I want to make sure everyone understands that was actually completely incidental. It wasn't a pivot, because a pivot is when you stop doing something and you change your mission. We were still going along the mission, but we realized that, look, if people couldn't even install Matplotlib and SciPy, they're not going to be able to install LLVM and JITs and Jupyter Notebook type things with requiring Haskell to do pandoc conversion, right? All this stuff was completely going to be off the table if they couldn't even install Matplotlib. So we just happened to create Conda and Anaconda as a way to solve that problem, so we could deliver more amazing tools into people's hands. And just to underscore that point, we actually did raise investment to create the company. We had a business plan. And so you can just imagine going to investors and telling them, our clever business plan is to build a package manager for Python. And Python's a free language, and so we free package manager. We're going to spend a lot of time hacking makefiles and debugging compiler errors so that we can build cool packages. And then the investor would say, well, okay, and how much can we charge for the packages? And our plan is going to be, we're going to give them away. And we're going to build more open source to give away. And you imagine the investors would look at you like you're kind of insane, right? It's almost as insane as like abandoning your family on a tiny planet, turning yourself into a maximum security prison, blowing up an entire intergalactic government, and killing multiple clones of yourself just to get McDonald's Szechuan sauce, right? That's how insane of a business model that would be. So us going and building Conda as the business model, that was never the business model. It was about much greater things than than package management. But anyway, as a result of what we have done, I think, by making Python easier for people to get, by making Python, creating infrastructure so more people can build libraries and share them. Conda Forge, the Conda Forge community, has now something like 2,500 different recipes and over 500 contributors. Those are, the Anaconda team is less than 10 people. There's 500 people building recipes out there. It's really become an ecosystem, and it's a really powerful tool. So we're really, really excited about all that. And so the situation in 2017 is much better. We have everyone learning Python. Major universities are standardizing on teaching it to their freshman classes. It's proven in production at serious places. Everything from hot, shiny little startups, not little anymore, I guess, but Silicon Valley startups like Airbnb, Instacart, things like that, to really very large, serious businesses like GE and JP Morgan and things like that. And it's basically ended the scripting language arguments, between Ruby and Perl and all this other stuff. If all you're trying to do is build like a blog in 15 minutes, okay, maybe Ruby on Rails versus Django is worth having a discussion. But if you're going to do any kind of analytics on that, you're not using Ruby, right? So it's really the Python's broad platform power of having so many different kinds of tools available, and now having a way to get all of the scientific numerical tools, data analysis tools easily, has just really put a lot of juice into the ecosystem. And really, the panel yesterday, Prabhu asked about the Python 2, Python 3 thing. I think we've actually weathered that bump pretty much at this point, that people are starting to make a lot of things available with Python 3. Many people are just learning Python 3 by default. And then in about 2.5 years, a little less than that, Python 2 will be completely sunsetted by the core devs. So I think we're going to, get past that. 5 years ago, it wasn't clear that was going to be even possible to get over the hurdle. And just to show how broad and popular this stuff has gotten, I want to show you, this showed up actually a couple months ago, but it's an Yves Saint Laurent perfume advertisement. And it features this very handsome artificial intelligence researcher who rides into like a warehouse hackerspace thing on a really beautiful motorcycle. And when it shows him doing his AI work, it's got a screenshot of an IPython prompt. And so I don't know if he smells like this perfume. I don't know if smelling like perfume helps your models converge faster. But you know, clearly Yves Saint Laurent did their homework and they realized, hey, we got to show something like a Jupyter notebook or a IPython prompt. So when your open source tech makes it into a perfume ad, you've definitely crossed over into the mainstream. Right? So I think we've done pretty well. Yeah, that's right. But it does raise the question, though, even though we've had these successes and you know all this stuff is going well, I think we need to take a principled look at why should we use Python for data analysis? Is it because it's so new? Is it because it's got these latest greatest libraries, TensorFlow and these other kind of deep learning things are all happening in Python? And it's worth looking back at the tech that is commonly used for data analysis. So Python and NumPy are definitely newer than the old things like SAS that it's displacing. But it's actually still pretty old. Python is 24 years old, and NumPy is 10 or 11 years old, depending how you count it. And actually, the vector computing idea is in NumPy. The idea that you can take a gigantic ND array called A and multiply it element-wise, or do a dot product against some other vector or things like B. Those ideas actually come from APL and Fortran, which were built in the 1960s. So the ideas there are actually pretty old. And I think that so the new technologies like machine learning happening in Python is an important thing. But I think the real strength of Python, the key value proposition for Python data analysis lies in a different aspect of it. And so NumPy is derived from Fortran, like I mentioned, but Python itself has a different influence. And one of the influences is a language that Guido worked on called ABC. And actually there's a little bit of it's a Wikipedia entry shown there. And you can sort of see that Python sort of inherited some of this characteristic, right? Easy shell scripting, values included for doing simple or common sorts of things, and not meant to be a systems programming language. It's garbage collected, doesn't give you manual control over memory, and it's intended for quick prototyping. So I would like to say that Python is the only major modern application development language that actually had its roots in a teaching language, like ABC. Pascal is a teaching language, but it's not really that majorly used anymore. C, C++ are definitely not designed to be teaching languages. People force themselves to learn it. And so this is actually a really important point. So before you had the Zen of Python, before you had import this, before you had readability counts, before all those design ideas, the creator of the language started with the ethos of building a teaching language that was accessible by design. And throughout the history of the evolution of the language, many of the core contributors, they carried on that ethos, that readability counts. There should be one obvious way to do it. It's one of the fundamental design guidances of Python. And the way that's manifested, or one of the implications of that, is that we've actually been able to reach across a broad spectrum of users. So now we see, nowadays, software developers are not the only ones that need to or want to code. The lights are sort of off, but I'm curious, how many people in the audience, by a show of hands, self-identify as software developers? Like, you get paid for code. It's not, this is a programming language conference, let's be clear, right? And it's something like 30% of people raise their hands. That means the other majority of people in this room are learning or coming here to geek out about a programming language and its libraries, even though they're not software developers. That's insane. If you go to a Ruby conference, if you go to a C++ conference, a Java conference, and you ask that same question, the entire room's hands would be up, right? So this is a really interesting aspect because the world is moving to a point where in every business, in every organization, in every aspect, maybe research, cancer research lab somewhere, or brain research somewhere, in all these different organizations, people have to use computers to think. And it's not just the software developers. We no longer just rely on traditionally classically trained CS majors to go and be a bottleneck for transmitting human ideas and questions to computers, code, data. So inside organizations, I spend a lot of my time talking to businesses and business users of Python. And what I see is that many businesses and organizations, they form these silos around tools. Essentially. Somewhat around business concerns and accountability, but they all grow their own sets of tools. And within many organizations, maybe this looks somewhat familiar to you, you have people who are called business analysts maybe, right, or data analysts even sometimes, and they're really stuck in Excel land. They might use more advanced tools like Tableau or QlikView. They might use even more advanced tools. They might do like VBA scripting and things like that, but they're really sitting there in Excel land. And they're using these tools to derive insight. They've gotten some data, they're just trying to either build a report or find some anomaly or something like that. And then on the other end of the spectrum, you have programmers who don't get paid for insight, they get paid for code that conforms to some kind of specification. And they have their tools, right? And their tools are fantastically designed for software development, building robust software systems. And now more and more of those people are filtering into and bleeding over into IT and development and deployment with DevOps and things like that. So that's becoming a really interesting space as cloud starts becoming a major part of everyone's lives. But ultimately, the end game is that programmers and the IT staff, they're paid for code that conforms to a spec. And in the middle, it's always been a small sliver of people, even at very large investment banks or credit card companies that rely heavily on data analysis, maybe risk modeling and insurance companies. There's a small group that you'll sometimes find called the Advanced Analytics group, or usually it's a risk modeling group. They need to do really sophisticated statistics and analysis, and more they're faced with large data sets and even more advanced approaches for doing prediction. And they're turning to Python, right? They've traditionally used things like SAS, maybe SPSS, but they, or sometimes they use R, right, or MATLAB, even Mathematica sometimes. But what we're seeing, and I'm really belaboring the point here, but Python can be used in every single one of these areas. And you might say on the left-hand side, well, what is the Excel person going to do with a Python script? But the interesting thing is that you can give an Excel programmer or an Excel user, you can give them like a Jupyter notebook. And even if they didn't know a single line of Python, they don't know the syntax, they don't know how to build packages or anything like that, they can read that code, assuming you did a reasonably good job. They can read that code, and if they want to change the query a little bit, they can change that query with some level of confidence. If they want a query instead of from a particular starting date to an end date, they want to change the dates, they can probably pattern match and get it right. If they want to filter out not just the names, foo, bar, and bass, but they want to add pork on the end of it, they could probably do that and not blow up, right? What I like to say about a lot of static type languages and sort of older languages like C and C++ is that really at any point in time, you're one semicolon away from a segfault. And in Python, you're actually much farther away, right? You can just kind of flail in different directions and generally hit something useful. And that's why Python is actually accessible to the Excel crowd, especially if data scientists in the middle do a good job of building reasonable notebooks for them. And so I think this ability to span the different areas is a very unique ability of Python. And the bridge, by the way, between the middle to the right should not be underestimated. If you give a MATLAB script, how many people here know MATLAB? Or edit a .m file, right? Yeah, a good number of people, actually more people than self-identified software developers. But if you hand a Java programmer a MATLAB file, how long before the Java programmer can correctly implement not just the logic, but the numerical accuracy, stability, and semantics of that MATLAB file? A long time, right? So Python, though, if you take a Python script that imported some SciPy, did some stuff, maybe there's some like weird calls to some FFT thing in the middle, but your Java programmer can look at a Python script and generally be able to get by, right? So I challenge anyone to find or come up with an example of another mainstream language that can cross these important silos, these very common silos. Because I think Python is pretty much the only thing. But that leads to a challenge too, which is just because a language can cross these areas, language and syntax can be used across these areas, doesn't mean the same person can write code for all three types of activities. So I sort of think that data scientists tend to use code the way that my daughter tends to use a hammer, which is that it can be surprisingly effective and usually there's minimal bloodshed, but it's not how you would build a house, right? And so the fact that it all looks like Python is a really common misperception, especially for upper management. Because upper management looks at IT, looks at analytics, they really don't know anything about anything, but they look at the stuff and they're like, okay, well, software devs, they're the ones with the code editors and the text files and all those like black backgrounds on their screens. Here's data scientists, they have black backgrounds on their screens, a lot of terminals and code editors. They must be all in the same group, right? And so, if you look at it, there's actually a lot of people who think that you can just treat data science as the same thing as a traditional software development activity. And it's really not, right? And Python actually, because it's such a fantastic glue language, because it's been around for so long, and because it came with batteries included, but has grown a huge developer community, you can actually do you can do a lot of things with Python. Now, there's lots of things we can't do still, but you can do a lot more with Python than you can with a lot of other languages. And that's led to the emergence of several what I would call different tribes in the Python land that don't really know much about each other's pain points. So the embedded folks probably don't know a whole lot about the 3D graphics people. The 3D graphics, people who are doing Maya and soft knowledge, these things that are scripting computer graphics, they probably don't know anything about doing Python data analysis. But everyone is using Python. And so depending on who you ask in the business, you're going to find that they have a different view of what Python is. If you ask, again, the IT, software, data engineering sort of view, they're going to say that Python is one of these alternatives for Java or even Ruby or C# or sometimes now Scala. Why would we use Python when we just use X? Because they're the same thing, right? And then if you go and you ask the analysts and the statisticians, they're going to say, well, Python is like this lesser R. And so why don't we use Python because we already have R? And so you actually find different people looking at this, there's that parable of many blind men in a room with an elephant, right? Well, now I guess it's a Python, and I guess you wouldn't grow the Python. You would figure out pretty quick it's a Python. But, just work with me on this. But the idea is that Python really has many different characteristics, presents itself as a many-faced sort of animal to who's looking at it. And I would encourage everyone in this room, as you're doing your evangelism, as you're describing Python to different people, advocating for it within your organization, keep this in mind. Keep in mind the kind of audience you're lobbying to, and make sure that they understand that this is a multi-headed sort of thing. And so anyway, despite those challenges and misunderstandings, though, I think the main promise of Python is that it can serve as an accessible data analysis language for the public. And many people, they rely on point-and-click tools, and I think that will continue to still be a very popular thing. But since coding is actually being taught at an earlier and earlier age to more and more people globally, we're going to rapidly enter an era where more and more people are able to at least reason a little bit about code. Maybe they couldn't write a whole thing from scratch. There's a pun in scratch, I guess. They couldn't write a whole thing de novo, but Python is an ideal way to give everyone access to meaningful code. And so I think of it as less of just a programming language, and rather I think of it more as like the new calculus or trigonometry. When you're faced with a lot of data, you're not going to just, it's not like what you learn in high school with all these analytical functions, but there is a kind of literacy, there's a kind of knowledge about statistics and code and data manipulation that you need to have. I really do think of it as a kind of literacy. And at the end of the day, I think in the future, to be an effective knowledge worker in virtually any domain, you're going to need to know basic statistics in Python. And if you don't, you run the risk of your job being replaced by someone else who does know Python writing a Python script. Because your job would probably be done a little bit better if you knew Python. So a line that I've actually said this to investors, because when we were going and pitching investors, like, well, so this is all interesting, but why are you so obsessed with this one programming language? And I tell them that this language is not like any other language. There's startups over in Scala land, there's startups around Node and JavaScript, but Python is not just software. It's this analytical language, and so it's thoughtware. The kinds of people that use Python, they're not going to learn a different language. They're not going to learn Haskell next year just because they saw another Hacker News article about it. They learn Python, they're going to do their job, and they're going to go home. They're going to come back next year, next decade, and if the Python still works, they're going to keep using Python. So it's really a very sticky thing. It's thoughtware. And the difference, another way for this crowd, I think I can explain the difference this way, that software is something that we use to tell computers what to do, but thoughtware is something that extends human abilities and makes the computer an extension of the mind. Those are very, very different kinds of things. And, thank you. In case you think I'm exaggerating, this is a picture, one of my favorite pictures from this year, actually. This is 1,200 students at the University of California at Berkeley. And I think it set a record for their class size at Berkeley. 1,200 students in the largest auditorium on campus. This is the introductory data science class being offered for the first time this fall semester. They're all learning Python. And these students are not majoring in computer science. These are biologists, economists, people studying humanities, people going to social policy, all walks of life. All these people, they have the gumption, they have the desire to go and learn how to do Python for data analysis. And that right there is the power of it. So then that's where we are today. We're in good shape. There's some things we need to do. There's things we need to tell people about the language and what it is and what it isn't. But what does the future hold, right? What is, not only the future for Python, but more importantly, the future for Python users and Python devs, people who are champions of the language. So I'm going to make a few predictions, and some of them are pretty obvious, and others are a little more subtle. I think that Python will become the preferred way to develop cognitive applications. And what I mean by cognitive applications is a very specific thing. It's a kind of application that exists, that is fundamentally tied to a particular kind of data set, a particular set of models. And so the round trip between the training data and the real application data, the data exhaust generated by interactions with users or external systems, those have to round trip back into the training, back into the testing, back into the regressions. And this entire thing is a cognitive application because it is data specific and data intensive. And I think people building those kinds of applications will more and more just adopt Python as the way to do it. I think that also there's going to be a steady income stream for people who want to maintain Python 2.x stuff. Because there's going to be a lot of it, it'll be around for a long time, and Python core dev, and SciPy core dev, and like the Matplotlib maintainers, and nobody wants to keep maintaining 2.0, 2.x code. But that's not to hate on people who are using it, it's just that you probably have to start paying for it. Another one is that multi-language compatibility is going to become greatly improved once people start adopting Arrow. I say storing data here, but really it's storing data in memory, so it's sort of a misnomer. But once people start adopting Arrow as a common data interchange format between language runtimes, it will fundamentally alter the landscape and make Python work much better with everything else. It will make other things work better with everything else too. R will work better with Java. It has nothing to do with Python. But Python entering into this kind of thunderdome of like all these different things, Python brings a huge amount of capability. So I actually think that Arrow is going to be our best hope for interop, long-term good interop with Java and the JVM ecosystem. And I think what we'll see is more and more Java technologies and libraries, things like Spark, they will move to using Arrow as the standard off-heap manager, non-garbage collected manager of memory. And so it's going to be a really interesting next several years. And lastly, I think that constant improvements in memory and in storage, as well as new kinds of hardware like GPUs and specialized tensor computation units, things like that, it's going to mean that people will do lots of Python on big workstations. Because those of you who have done machine learning for real, doing real data science, you know that in reality, a lot of your data exploration can be done in a single, fairly beefy machine. And you're subsetting the data anyway. You can't do exploratory data analysis on the whole data set anyway. So that's one of my predictions, is that everyone will actually talk about distributed. They talk about distributed big data way too early, I think. Most of the insights you can derive that are meaningful to derive can be done on a subset of the data that does fit on very powerful workstations. So I think the key thing to keep in mind, though, is that Python is what you make of it. So the language itself is constantly evolving, constantly adapting as the developer community actively drives its evolution. So if you want to answer the question of what comes next for Python, the answer really is, what are you doing about it? What are you making? Well, that's what's going to come next for Python. So that, and that's not meant to be just like a little gotcha or a cute saying. It's how Python has gotten to here. I remember early in the 2000s when we were looking at doing web programming with Python, there were a plethora of different kinds of tools and libraries. Then TurboGears and Django emerged as the two competing ones. There was a lot of pressure on Guido to actually, crown a king, so to speak, in that world. And he actually, believe it or not, Guido actually picked Django. He announced that at a SciPy conference. Alan Pasadena, someone in the Q&A section of his keynote asked him, and he came out and said, okay, well, based on, since you guys are asking me, I've already basically made up my mind. And he picked Django over TurboGears. And the reason for it was not necessarily because of technology, but he felt that the Django people understood how to grow a dev community. the user community, better than the TurboGears folks. And that was his call. But the point is, both of those, and TurboGears exists in sort of its own form now, as kind of the pyramid sort of stack. But the point is that all those tools and technologies that are now standard, they're created by people just like you. The future is made by people in the present, right? So this is something to keep in mind. And the fact that we have such an open source, such an open ecosystem, all the libraries we build are permissively licensed. It just basically reduces all these frictions for adoption and innovation and things like that. But an important thing to keep in mind about open source, while I'm talking about that, is actually I'd encourage people to have a very clear view of open source. And so if you ask a bunch of open source developers at a Python conference or a tech conference, or maybe even at like OSCON, things like that, you quickly find that the attitude about open source now is mature, but people are not just talking about licenses, right? It's not just, do you have this license, do you have that license. Actually, what they'll talk about is the spirit or the motivation behind it. It's about freedom, it's about an open community, or things like that. And the challenge that we see right now is that as the world of software development itself evolves into being more about infrastructure organization, orchestration, and self-deployed web-scale applications, more businesses are willing to adopt open source. But as the enterprise adoption of open source continues apace, it's really important for us to think about, one, sustainability. And actually, I'll talk about sustainability actually. The reason that more discussion of sustainability is happening is because there's been more corporate adoption. And there's been, you see it on Twitter and other sorts of places. NumFocus actually just had a sustainability summit in Austin where many dev leads came in to talk about this challenge of sustainability. And there are, so in Pi Data Land, we have a really good organization, NumFocus, to handle taking donations, things like that. But actually, there's been a lot of organizations, at least in America, that have donated money as well, whether it's granting organizations, government funding agencies, as well as corporations like Two Sigma, Bloomberg. They directly fund efforts around core Python technologies. But things like NumFocus help us, pull that money together, and it's sort of helping a little bit to get that enterprise adoption of open source to turn into some kind of revenue stream to help sustain developers who are working on open source. But one thing that I see a lot is that developers of open source misunderstand why businesses adopt open source. So businesses are adopting open source not really because they care about freedom or anything like that, but actually the key reasons that I've seen about business adoption is that they really just care about, one, not getting locked in. They really, really hate getting locked into a proprietary vendor, and many businesses now are done with it. So they're adopting open source, they're building some stuff internally on top of open source, they're self-deploying, and that's good enough. So that's one of the reasons to avoid the lock-in. And the second thing is that they want to harness innovation. And that's actually kind of a subtle thing. If you rely on a proprietary product and some new capability emerges in the world, you cannot bring that capability into your IT infrastructure unless the vendor has built it into the product. If you have open source, you are the master of your own domain. You can say, well, this year we will allocate budget, and we're going to go bring in some experts, we're going to bring some contractors, we're going to go and actually do this innovation intake ourselves. We're going to onboard this innovation. And so businesses really like having that freedom. For us in the open source world, we think of these kinds of things as happening very quickly, like, oh, this new cool thing came out for machine learning. Let's make sure we get it in the next couple of months. Business enterprise IT adoption can take years. It can take years. So many people are just now starting to finally productionize their Hadoop deployments, right? And they started 3 years ago. So this kind of enterprise lock-in and this gating of innovation is something that enterprises really resent. That's another reason why they adopt open source. But these are not two things that you hear anyone in the open source world really talking about as they're talking about sustainability and concerns around that. So I would encourage all of you, as you're thinking about sustainability, as you're promoting open source, understand that the reasons why you promote it to other devs and other people like you is very different than why business is interested in using open source. You must always drive to the why and the intent and the incentives behind people's actions. And so this is based on what I've seen in talking to businesses who are using Python for data science and data analysis. There is a small cost aspect to it because Python is much cheaper than SAS, much cheaper than MATLAB. But ultimately, it's these things. The fact that they know that data science innovation is happening very fast, machine learning AI is moving very fast. They don't want to have to wait for some vendor to delay 18, 24 months to give them some capability. So we have maybe time for questions, but I can also do another section on sustaining open source that I think this group might appreciate, but it means we'll have less time for questions. Who wants me to kind of continue on? Just show of hands. Okay. All right, not a very inquisitive bunch then. Okay, sorry. So along the lines of open source then, there's a metaphor that I really use to think about the essence of the value chain around open source. And it's actually around gardening, and I call it the Garden of Insights. And so if you think about gardening, some of you are maybe familiar with gardening. This is gardening in Farmville, where you put some stuff in and you wait a minute or however long, and then you get other stuff out. And it's a very simple, just combining of different source materials, and you get output products. Now, of course, real-life gardening is not really like Farmville, where you just combine things and it's a recipe and something comes out. Real-life gardening involves transforming things and tending to things. So it's not about grinding experience points or getting currency or things like that. It's actually about. Oh, is there a connection problem? Oh, there it is. Real-life farming is actually about managing an ecosystem and a whole balanced set of transformations. So I think of open source as sort of a community garden or a community orchard. And there's some open source devs that are going to set up a fruit stand, and they're going to put up an honor box. I don't know if you guys have this kind of thing in India, but in America it's quite common where smaller farms, along the side of the road, they'll just put some of their fruit and vegetables out for free and have a little box, and you just drop in whatever money you want for the vegetables and the fruits. It's just free food. You take it, you put in however much you think is fair. And so for open source devs, this might be like your Patreon account, right? Use my stuff for free, pay me, don't pay me, whatever. So there are going to be folks that drive by, they're going to grab a lot of this fruit, they're going to go to town, and they're going to sell them out the back of a truck where there's a lot more people than some rural road. There's others that are going to set up a small grocery store, on the side of the farm. And it's an organic local grocery. You know that when you buy this stuff, it's helping to sustain the farm. And the point is that there's many people who can all benefit from working together in this ecosystem. And so we have to ask ourselves, and when you have something like this, how do you make sure that it stays viable? There's actually very, very few historical examples that you can point to when open source communities were able to sustainably thrive based on a network of value creation, not merely the patronage of some wealthy corporate donor, like Google or Amazon or Apple giving a whole bunch of money to some open source thing, or sustained government funding. Right? There may be some government agency that really wants some open source capability. They put taxpayer money into it, and there it is. To actually find open source communities that have stayed long-term viable on the basis of a network of value exchange is very rare. But the history of software and internet technology is actually very young. So everything is still pretty new, right? So everything that happens is happening for the first time. And I would say the geography of the current technology landscape favors us. It favors open source. It favors people that are community-oriented and that have some business and entrepreneurial mindset in the middle of that. There's some open source communities that are religiously anti-commercial, and I don't think it benefits them to do that. I think the Python landscape is actually really nice because we have a lot of big companies. If you go to any Python anywhere in the world, you'll usually see Microsoft and Google and other big companies there that are international. If you go to the ones in the United States, you'll see a lot of the big startups. You'll see Facebook and Apple and Airbnb and all these other people there. So the Python world is not against commercialization. So I think we're actually set up to do this well. But the challenge, though, as we grow as a community, I think the challenge is that when we think about sustainability and future viability, we don't have a lot of examples to reflect upon. We really have to make this up on our own as we go along. And so, what are we farming? If you think about, again, the farm, and you talk about the orchard, and maybe apples and other things growing on trees. When we farm, what are we actually doing? With a farm, it's easy to look at fruits and vegetables. It's easy to look at things that are coming off of the plants and to say, well, that's the value of the farm, right? But that's not the value of the farm. The trees and the trees themselves that bear the fruit, they're the ones that you're actually tending to, because year over year you want them to continue bearing fruit. But if you go and you look more deeply at farming and farm management, you realize it's all about water and soil management. It is actually the soil and the water that determines how long-term viable your farm will be. And that's your long-term equity. So I would encourage people to think about this metaphor in the metaphor of the community garden, and how we can be all unique stewards, good stewards of this really unique verdant valley of Python, right? And I think the most precious natural resource that we have in this farmland is human creative potential. So that's the soil. That's really the soil. That's the water. That's ultimately making all of these things possible. So it's not about any particular tool or any particular library. It's not about any fruit that comes out of that library, an application area for a particular library. Those are important. We have to do those right. We can't let worms and pests take out our crop. But ultimately, if we think about ourselves as a community of technologists, of enthusiasts, many of us here have a passion for Python. We have to ask, why is it that we care about Python so much? Is it just really because I like having white space for indentation? And it's not that, right? It's actually that we like the people we meet at Python. We like the kinds of ideas that we hear. We like that it's an open and welcoming community. And we like that many people in Python land are very broad thinkers, and they're looking at the world and trying to solve problems in the world. That energy, that's the soil, that's the water, that is our equity that we have in this community. And I would encourage all of you to think about how you manage that, how you contribute to growing that community, because it is on all of you to grow that community. So Brett Cannon, I saw someone wearing a shirt, I think. Brett Cannon has this really great saying that I came for the language, but I stayed for the community. And that's really a beautiful statement about why Python is so strong and continues to grow so strong. The Python community, there's something I heard many years ago when people were still fighting R versus Python, and they say, well, R has a really huge user community. And it took me a little while to come up with a good rebuttal to that, which is that Python has a really huge maker community. And that's really big. That's a big distinction. The R world is actually very bifurcated between tons of academic users and a very few people that actually create the core things. Python land, we reach across silos. We have all these different ecosystems that thrive inside this language. And all of those are because we have a large maker community. People want to get their hands dirty, want to build things. The instant they start making something for themselves, they want to start sharing with others. That is an incredible potential, that's an incredible orientation that we have. And I encourage all of you to continue growing that spirit. And it's really wonderful to see so many different Python meetups and Python conferences happening here in India. I gave talks in Spain and in Japan earlier, just the last couple of months, and it's the same energy everywhere globally. It's a really, really powerful thing. It's no longer just a community, it is a movement. And you are all members of the movement, which means that you are responsible, right, for carrying that movement forward. So thank you very much for having me. It's been a wonderful